Okay, so let's do this this problem of a person exercising. And we're told when a person exercises, we have the 60 kilogram person, that 800 kilojoules of heat is released into that person's body. And we want to go ahead and calculate if that heat is put in the person's body, by how much will it raise their body's temperature. And so our expression that relates heat to temperature change is this, mc delta T. And we're told that 800 kilojoules of heat are put into this person's body. So 800 kilojoules is 800,000 joules. Okay? And that equals the mass of the person, 60 kilograms. Now we need to look up the specific heat of a human body. And this is actually listed in the table in the textbook. The specific heat of a mammal is 3,400 joules per kilogram degrees Celsius. So joules per kilogram degrees Celsius times delta T, our temperature change. Okay, so we've plugged everything into this into our equation here. We take 800,000 joules, divide it by 60, divide it by 3,400, and the temperature change we get is a fairly significant one, 3.9 degrees Celsius. Now, in terms of Fahrenheit, that's about 7 degrees Fahrenheit. So if normal body temperature is about 98, 99 degrees, this amount of heat released into your body would make your body temperature 105, 106 degrees. And of course, your body can't function at that temperature. So that's a significant amount of heat put in the body. And that's basically where sweat comes in. That heat gets removed from your body by the evaporation of water, sweat, from your skin. And what we're going to do in part B, so here's part A. In part B, we're going to calculate how much water needs to evaporate to remove that much heat from a person's body. And this is a phase change, and our expression for the heat from a phase change is this. It's the mass of water times the heat of vaporization. Okay? So if we're trying to dissipate 800,000 joules of heat, there's our Q. And that equals the mass of water evaporated times the heat of vaporization of water. And they're looking that up in the textbook. That has a value of 22.6 times 10 to the 5 joules per kilogram. Okay? So 800,000 divided by this number gives you a mass of water which is that evaporates 0.354 kilograms. Okay, so there's our answer. That's how much water or sweat needs to evaporate from this person's skin so that their temperature doesn't go up. Okay, now how much is 0.354 kilograms? That's about 3/4 of a pound. Okay, so that's not that much water at all, really. That's about 12 ounces. Okay, so basically like a 12-ounce can of water that would evaporate from your skin during this workout.